extraterrestrial life, but this argument, that is a not typical argument for a masterclass, is for sure a scientific part that could be discussed using our scientific research. During this week, you had a lot of lecture about high energy physics, accelerators, but the most important things that you have to learn during this week is the scientific approach that you could have to such problems. This means that you have to learn how to think as a scientist. You have to apply the scientific method also to some problems that are not considered erroneously, as in this case, part of our scientific research. As you know, search for extraterrestrial intelligence is considered a matter of fanatic, crazes, fans, Star Wars, etc. But this is not real. Because generally, when someone speaks about the possibility to find extraterrestrial intelligence somewhere in our universe, normally people think about sighting, alien contacts, abductions, etc. But these, let me say, between quotes, proofs, are mostly publicized on internet, but are only fakes realized to make disinformation about these items. So now in this presentation, what I want to show you is how the scientific research has approached to this problem during years and what are the conclusions that we reach. The main questions that we could have are the following. Is it possible to perform a scientific research for extraterrestrial intelligence? Or scientific research has never tried to search for extraterrestrial intelligence, and as I will show in this presentation, some important names of physics and of research, like Enrico Fermi, Frank Drake, has tried to search for extraterrestrial intelligence. Let me start from 1950, when during a lunch, Enrico Fermi, Teller, York, and Konopinski, not normal guys, are discussing, as the Chronax reported, are discussing not about soccers or teams, but about some mundane problems. Now, the question is they are discussing about some mundane problem during a lunch. And one of these problems is for sure the existence or not of intelligence and life outside our Earth. During this lunch, Fermi formulated what became known as Fermi Paradox. The Fermi Paradox is simple in this sentence. Where is everybody? What does it mean? In other words, if the extraterrestrial civilization exists, why we have not met them till now? This is the Fermi Paradox. If we consider that in our galaxy, the Milky Way, we have something about 100 billion stars, and we have something about 100 billion galaxies in our universe, and planets are commonly and uniformly distributed in our universe. And if we consider that the only example that we have is the Earth, and on the Earth, that is a rocky planet, the life is present, and we could define intelligent life, let me say. And if we consider the long age of our universe, then we could expect to have a large number of civilizations in our universe. So now the point is the following. It's only a matter of time before this civilization develop the ability for intergalactic travel and are able to meet us. Really, given a response to Fermi Paradox is not simple and requires a deep analysis that is not only concentrated in physics or astronomy, but involve, as you will see in the other slide, also some other branches of the knowledge. possible answers of the Fermi paradox are the following. If we consider that an extraterrestrial intelligence exists, we could think that they has not yet civilized the entire galaxy, or they are not inside our galaxy. This means that this extraterrestrial intelligence is too far from our Earth. Or otherwise, they exist, but they don't know where we are. Or they know where we are, but they don't want to meet us. On the contrary, we could conclude that now extraterrestrial intelligence not yet exists. Observe that I have not wrote extraterrestrial intelligence do not exist. I wrote not yet exist. So when we speak about intelligent life somewhere in our universe, we have to do some important consideration. First of all, a bacterial colony somewhere in some planets is for sure a form of life. But this is not what we want, an intelligent extraterrestrial life. These intelligent extraterrestrial lives must, first of all, be in a planet that is close to us, because they have to reach our Earth. And must be also able to communicate outside their planet, and moreover, this last item is the most important, this intelligence must exist now. If we consider the age of the universe, and if we think that, for example, 100,000 years ago, an extraterrestrial intelligence developed somewhere in the universe, also close to us, and reached our planet, but we are not yet on Earth, this is not a possible communication between two civilizations. So we have to include also the timing information on this analysis. Looking at all these aspects, what we could do scientifically is perform a statistical analysis of this problem. And all these aspects that we already discussed could be included into the equation that is called Drake equation. That is an hypothetical equation created during 1960 by Frank Drake. Now, when we speak about Frank Drake, we are not speaking about a normal man. We are speaking about a scientist. Frank Drake was an astronomer, an astrophysicist, was a full professor at Cornell University, and director of the National Astronomy and Ionosphere Center. So we are talking about a real scientist which approach to this problem. Now, if we define Sn the number of communicative civilization in our galaxy presently, we could obtain this value statistically using this formula. Sometimes this equation could be also written in a different form, but with exactly the same meaning for the result and for the single terms. Now, what are all these terms? We have to perform a statistical analysis. The same statistical analysis that every day we do, for example, analyzing data from LHC or from CHLOE, from an high-energy physics experiment. If we want to obtain this number, first of all, we have to consider the number of stars that are present in our galaxy. Now, we have a sample of bodies in our galaxy that is the number of the star. We have to consider not the entire sample of these stars, but only the stars with planets around them. And this reduces the number of events in our sample to a less sample. Then the planets could be Earth-like, this means rocky planets, solid planets, or also gaseous planets. For sure, if we consider the possibility to have life in a planet, a gaseous planet does not satisfy our request. So we have to concentrate not to the entire planets rotating around star in our galaxy, but only in the planets that are Earth-like. But this is not still sufficient. because the condition on this planet must be sufficient to create and develop life. This means that these planets must have some important parameters that is able to satisfy the condition for life. In this case, what we could have a fraction, only a fraction of this sample of planets Earth-like in which we could develop life. And we have to consider not only life, as said before for the bacterial colony, but only intelligence life. And moreover, we have to consider the timing information for this civilization, because we want that these two events are synchronized now, exactly at the same time. And we have to consider that this intelligent form of life must communicate outside their planet. If we try to solve this equation, we could analyze the single term of the Drake equation to obtain the result of this equation. First of all, the number of stars in our galaxy is an information well known to astronomers. We know now that the number of stars in our galaxy is between 200 and 400 billion. And we have to consider also the ratio of stars formation in our galaxy, the new stars that appear every day. And this is the first term of our equation. Now, if we want to concentrate our search to the fraction of stars that has planets that are Earth-like and that is able to develop life, we have to consider these three terms of the equation. Surely, this is also a matter of astronomy. We are able to identify planets. Where we have to look for life? If we consider the only example that we have, that is Earth, we have to consider only planets in which we could have carbon-based life as humans. Now, to define these planets, we have to consider some parameters of these planets that are for sure temperature, the presence of gravity, the density of the planets, if this is a rocky planet or a gaseous planet, the orbit, and the presence or not of liquid water, and etc. Actually, we have a lot of telescopes, both on Earth's surface than in orbits, that explore the universe to search what we call exoplanets. These exoplanets are planets orbiting around the central star outside our solar system. We have a lot of solar system or star system in our galaxy, and our solar system is only an example of this. This search, for sure, is made look outside our solar system, but we have to find planets that are in the so-called habitable zone. What does it mean? If the planets that we select is too close from the central star, the temperature will be too hot, not adapted to become life. If the planet is too far, the temperature is too cold. Moreover, we have to do some consideration also on the orbit of the planets. You know that the kinematics of the orbit is due from the Kepler laws. If we have an orbit that is too elliptical, the temperature difference between summer and winter in these planets is too high. And in this case, we could not be able to develop life. In 1960, when Drake wrote for the first time his equation, the scientific community do not know any exoplanet outside our solar system. They are still discussing about this problem. Now, we have identified more than 1,000 planets outside solar system in more than 800 planetary systems. To identify, this is a plot that shows the number of exoplanets found for every year. And to identify these planets, what we do scientifically is use a telescope to observe a star, measure the brightness of the star. Now, if we have our telescope, the stars, and the planets that rotate around the star, when the planets pass between the stars and the telescope, we have a decrease of the brightness of the planets. So, observing the decreasing in the brightness, we could identify the number of planets, the orbit, the dimension of planets, and we could obtain also some very important information about the physics of this planet. Up to now, in this sample of more than 1,000 exoplanets, the best candidate ever found is Kepler-22b, that is an exoplanet in the Cygnus constellation, more or less 600 light years far from the Sun, from our Sun. And this planet is the better candidate ever found to be in an habitable zone of the solar system. Kepler-22b rotates around Kepler-22. The name indicates B because it's the second planet found in this planetary system. Rotate around Kepler-22, that is a yellow dwarf, and rotate in 219 terrestrial days. This is the length of the year for Kepler-22b. And the name Kepler means that this planet was found using the telescope Kepler that is orbiting around Earth. The average temperature on this planet is between -11 and +22 degrees centigrade. This variation depends on the presence or not of greenhouse effect, because now, using Kepler information, we are not able to determine the presence or not of greenhouse effect, that, as you know, is very important also in Earth to maintain a stable temperature on our planets. So, from this consideration, we found the probability, I repeat, to have an Earth-like planet in the right zone of its system in which life can be formed. Now, to evaluate missing terms, astronomy is not sufficient, because for the other parameter, and I mean the possibility to develop intelligent form of life that are able to communicate outside, and they exist now, we have to consider also biological, social, anthropological, and historical development of this extraterrestrial society. So in the formulation of the terms that enter inside the Drake equation, we have to involve not only physics and astronomy, but also social science. And when we consider this parameter, we have never to forget the uncertainty. Since this is a statistical analysis, we always have an uncertainty on this parameter. And since we have only one example, that is our Earth, the statistical uncertainty on this parameter is very high, at the level of 100%. In 1960, when Drake formulated this equation, he obtained a number of 10 that is 10. What does it mean? From a statistical point of view, in our galaxy, there are, in average, 10 planets with intelligent life able to communicate with us presently. Using the better astronomical values that we have nowadays, the current value of n is about 23, but with the same order of magnitude of the results obtained by Drake. Now, concerning the uncertainty, following different position of scientists in physics and also experts of social science, the value of n could oscillate between 1, could not be lower than 1 because in our galaxy we have the Earth, and 600,000. This means that the uncertainty of n is very, very high, and we go from a value that say that this presence is absolutely probable to the value that say that is absolutely not probable. So, if we consider the possible solution of the Drake equation, we could also consider that we could suppose that an extraterrestrial intelligence exists. This is not crazy, because this is a possible solution of our statistical calculation made using Drake equation. So now, if we want to perform a communication test, what we have to do? If I want to speak with you, I speak and you listen, or otherwise, you speak and I listen. So we have two possibilities. We could try to send signals, or we could try to listen signal from universe. In this game, a very important role is for the radio telescopes. These are telescopes which observe our universe measuring radio waves. This picture represents the radio telescopes in Arecibo, in Puerto Rico. And this telescope is managed directly by the Cornell University. And this is the world's largest single aperture telescope with a diameter that is greater than 300 meters. Why I report this picture? Because concerning the SPEAK test, in 1974, using Arecibo telescope, we made a test. We tried to send a message in the universe, and we prepare this digital message, that is a sequence of 0 and 1, that was sent toward the cluster, the globular cluster M13, that is 20,000 light years away from our sun. This digital message is a summary of our knowledge. Now, consider that we want to perform a test. We want to try to talk with an extraterrestrial intelligence. Which kind of message we send to this civilization? This Arecibo message was realized directly by Frank Drake, together with some collaborators. And this message that appears like a sequence of 0 and 1 without sense, if we consider the bit that are 0 as off and the bit that has 1 as on, we obtain this pictorial view of the message that is a sequence of drawings. What does these drawings mean? If we start from the upper part, we have the number between 1 and 10. Then we have numbers 1, 6, 7, 8, and 15, which correspond to the atoms in the Mendeleev table corresponding to the atom which enter directly into the DNA molecules. Then we have the right sequence of the molecule of the DNA, together with the famous double helix. We have some information about humans. We have a drawing of a man, the average age and the world population in 1974. Then we have a map, our solar system, just to say to this civilization that we are in what we call solar system, with a map to find them. And also we have a telescope to demonstrate to this civilization that we are able to communicate with them using a radio telescope. Can this message be considered a tentative communication test? Probably no. Why? M13 in 1974 was chosen for the high probability to have habitable exoplanets, but it is only a guess, because in 1974 they not yet know any exoplanets. And moreover, M13 is 20,000 light years away from us. This means that if now we send a message to M13, this message requires 21,000 years to arrive. Then the extraterrestrial intelligence has to receive our message, prepare their answer, send the message, and this message requires other 21,000 years to arrive to us. So this message is completely unuseful. And moreover, since galaxies rotate around the center of the universe, when our signal reaches M13 is not in the same position because it's moved. So the question is why we sent this message in 1974. This is only a spot for the Arecibo telescope because in the same years, using Arecibo telescope, Hulse and Taylor identified for the first time the class of star that we now call pulsar. So this tentative communication is only did to increase the attention of the people on the radio telescope and to demonstrate the power of this telescope. But we have the other test. We could try to listen. But now, if we want to listen some signal, we have to answer, first of all, to two important questions. Which signals we want to listen? And from where? Because in principle, we could not think to receive all possible frequencies that are infinite from every part of the universe. So we have to answer to these two questions. First of all, scientifically, which signal I could try to listen. To avoid background contamination, we have to select frequency in which there are no known sources in the universe. What does it mean? If I select a frequency, and I know that, for example, pulsar emits at this frequency, I have a lot of background in my search. So I have to study the spectra of the natural emission of the universe, and observing this plot, we notice that there is a flat and clean band here between 1 and 10 gigahertz. Moreover, in this band, we have also the emission from hydrogen and oxygen-hydrogen molecules. That is one important sign of the presence of life in our universe. So we could use this frequency because we have less background and because are important for our search. But now, from where we have to search for this signal? For sure, we could use radio telescope. And we could point our radio telescope in a certain direction to try to listen signals. But if we observe this map, that is the map of the stars within 60 light years from Earth, which contain exoplanets that could be habitable, we observe, as astronomers always say, that our universe is homogeneous and isotropic. So this means that we don't have a preferred direction in which we have to try to listen this signal. So this means that we find right frequency band, but we don't have a preferred direction to search for these signals. This means that we have to sweep the entire sky randomly. But this test is still in progress, and the most famous project for signal listening is for sure the SETI project. SETI is an acronym which stands for Search for Extraterrestrial Life. It is a project proposed initially by Drake in 1974, and is constituted by a network of radio telescopes which try to sweep randomly the sky to search for the signal between 1 and 10 gigahertz. There are some important criticisms to this research, also from the scientific point, but this always is a scientific research, because sweep the entire space without a preferred direction is like to look for a needle in a haystack. Currently, we could not know when, but especially if, this project will find something. And moreover, suppose that we catch a signal, only one signal, only one time. What we could conclude? From the statistical point of view, we have one event with an error that is 100% uncertainty. Why I did this example? What SETI has found up to now? On 15 of August 1977, the radio telescope Big Ear in Ohio listened a signal. This signal is named WOW. The name is due to a comment written by Heman, that is a volunteer of the SETI project, who wrote WOW when he looked for the first times at the signal. This signal is very short in time and with very high energy. But we observe this signal only one time and was never repeated again, also using more sensitive equipment. But let me explain better this signal. Big Ear, that is the telescope that observes this signal, is not a classical radio telescope with an antenna. It is something fixed to Earth, which explores the different parts of the universe thanks to the rotation of the Earth. So when the Earth rotates, Big Ear could explore different parts of our universe. This means that a possible signal could be observed only for 72 seconds. Why? Suppose that we have a source here. Big Ear is rotating. When this source arrives, the signal from this source arrives in the fields of Big Ear, we could have a ramp up of the signal, then a maximum when these two are perfectly aligned, and then a ramp down when big ear is moving from the perfect alignment. And this is the shape of the wow signal. This signal matches exactly what we expect from an extraterrestrial source. What was wow signals that was identified coming from Sagittarius constellation? Today, we still not know what this signal was. We are sure that this signal did not came from Earth or solar system, but we still not know what wow was. This is a typical event with a statistical uncertainty of 100%. What is the conclusion of this presentation? As I shown, there were and there are for sure scientific searches for extraterrestrial intelligence, but up to now there are no proof for the existence of extraterrestrial intelligence. As seen, what we could do is not wait and expect aliens coming with UFO. Scientifically, we could analyze and, for example, making statistical guess on the existence of extraterrestrial intelligence. But we have always to consider the uncertainty in this kind of searches. What is the answer to the Fermi Paradox? Where is everybody? From our analysis up to now, we could conclude or they do not exist, or otherwise they are somewhere in the universe in a region that is too far from us, or otherwise not in our galaxy. And now the questions always present is the following. Could a scientist believe in extraterrestrial intelligence? For sure, yes, but this is matter of personal considerations, not motivated by scientific proofs. My personal position is the following. Extraterrestrial intelligence may exist, for sure, but up to now we cannot nor exclude or confirm their existence. Let me say that considering human the only form of life is a sort of anthropocentric consideration that is not matter of science, because statistically, if the life is present on Earth, could be present somewhere in our universe. From a scientific point of view, if an intelligent life is present on Earth, it may be present in other planets, but these planets could not be inside our galaxy. This conclusion, for sure, does not imply necessarily the possibility to meet extraterrestrial intelligence, and the only way that we have is go ahead in scientific research, because only in this way we could learn step by step, also slowly, let me say, the always still present secret of our universe. Thank you.